Hello guys, welcome to another session of Math. I hope you guys are doing good. Um, we are going to look at how to solve this problem using Lambert W function. In our previous video, we used that approach, and so this question here, we're going to use Lambert W function. Actually, somebody requested or asked how he can use Lambert W function to solve this problem. So it's not only Lambert W function that can be used to solve this problem, but sometimes it may be possible or sometimes it may not be all possible. But in this video, it is possible, but it can be that in yours or particular question that you get, it might not be all possible. So it does not mean all problems of this nature are solved by what you are going to see in this video. All right, so I'm just going to show the person who asked how he can use the Lambert W function to solve this problem. Yeah, he requested it. He wanted to use Lambert W function, though the answer is what? 1. By just looking at it, the answer is just what? 1. But you want to find out how we can use the Lambert W function to solve this one. Okay, so all of us are just going to benefit from what the guy requested. If you can, you can also pause the video and then try, or if you don't, then stay then make sure you watch it to the very end. But actually, this equation here in this video, we are not just going to use the Lambert W function approach. We are just going to use indices and the Lambert W function approach, because by just looking at it, you can tell s is equal to 1. So if you use indices, you can also get the 1, and then when you use the Lambert W function, you can also get the 1. So I'm just going to show you how you can use the indices to solve this particular problem. I'm showing you the indices approach because, as I said earlier on, not all problems of this nature are solved by or can be solved using the indices approach. But when you get it, looking at how the indices approach was applied to solve this one, you can try using it. If it works out, fine. If it doesn't work out, then you move on to the next approach. That is why I'm just going to show you the both methods. Okay, so we are going to first look at the indices approach, and then later on we look at the Lambert W function approach. All right, please make sure you share it with your friends, and also comment, like, and then hit the subscribe button so that you get notification anytime I drop out a new video. All right, good. Let's first look at the indices approach. So I'm writing that one here using indices approach. Indices, that is power, base, something like that. How we can use that one to solve this problem. Right, so let's write the question. 3 to the power x plus x equal to 4. As I said earlier on, by just looking at it, you can tell s is equal to 1, because if you put 1 here, this one 3 raised to the power 1 is what? 3, and then plus 1 is what? Just 4. It's 4. S is equal to 1 by just looking at it. But if you want to work the 1 out, how are you going to do it? As I said, we are using the indices approach to work it out, and after that we move on to the Lambert W Function approach. Well, what we are going to do here, since we are using the indices approach, we are just going to rewrite this 4. We will write it to look like this expression here. Here is 3 raised to the power x plus x. It can be 3 raised to the power y plus maybe another variable. Okay, and then so we will just write this 4 to look like this one, not the same thing as this, but to look like this, so that we can do comparison to find the value of what? X. Now let's find out how we can write this 4 to look like this. 4 is same as 2 plus 2, right? Is same as 4 plus 0. But when you write it as 2 plus 2, does it look like something like this? It doesn't have any power, and all of them are just we say just whole number, like a base, 2 bases, just like they got no power. The powers are just raised to the power 1. So if you do comparison, it's not possible. Even when you look at this one, it had a base of 3. So if you use 2 plus 2, the comparison won't work out for us. Okay, good. What about how should we write this? All right, let's go. Okay, since we want this one to look like this, we are just going, let's try 3 plus 1 or 1 plus 3. 3 plus 1 or 1 plus 3. 3 plus 1 is equal to 4. 1 plus 3 is also equal to 4. When we use it, let's see if it's going to work out. 3 plus 1, when you compare 3 plus 1 to this, I think it is a bit better than 2 plus 2. Why? Because when you take the first one, which is 3, and you compare it to this one, I think you can get the value of x using the indices approach, because the power of the 3 is what? 1. And here the power of this 3 is what? X. So since they got the same base, which is 3, we can equate the powers, which at the end of the day is going to be x equal to what? 1. And then when you look at the other one, here we have a whole number, which is what? X. And then the other one is what? Plus 1. So we can just say x equal to 1 by just what? Doing the comparison. Alright? So we are just going to rewrite this 4 using 3 plus 1 or 1 plus 3. If you write 1 plus 3, it is the same thing as what? That. Good. So as you can see, the comparison will just work out for us easily, because here the base is 3 and the power is what? X. When you come here, the base is what? 3. The power is what? Though it's not written, but we all know that when the power is not written, it is what? 1. It is what? 1. So the power is what? 1. And also when you look at this, plus 1 here, plus x. When you come here, plus 1. Easily we can tell x is equal to 1. But it will be the same thing as when we equate this one to this. I think so. Why? Because the base here is the same thing as what is here. So x will be equal to the power here, which is what? 1. Okay, good. So by comparison, this is equal to this, or this is equal to this. But make sure that any of them that you compare should give you the same answer. Alright? If one of them give you an answer which is different from the other, it means your approach or what you are doing is not the correct answer. So x is equal to 1. Let's find out from the other one too if that one will also give us x is equal to 1. Or 3 raised to the power x is equal to 3. Now the base are the same. What is here is the same thing as what is here. So what is here? What is going to be here? We all know is 1. So if 1 is here, what is going to be here? Definitely the same thing as what? 1, since what? They are equal, right? So by equating exponent, x is equal to 1. So by exponential equation, you can also say by exponential equation or by equating what? Exponent. So x is equal to 1. Now from the indices approach, we had the value of x from the equation to be what? 1. You see, using the indices approach, it was, though the what we are actually solving is very, very simple. Even as I said earlier on, if you just look at it very well, you can tell x is equal to 1. Good. That is the figure. When you put into the equation, both left and right hand side will be all the same. But the question is, it's equal to 1, but how are you going to work out the 1? So if you use the indices approach, that is how you should go by. But well, now we are moving on to what the guy requested, and his name is what? Lucky. His name is what? Lucky. He requested it. So they're just going to find out how the Lambert W function can be used to solve that problem. Okay? Yeah. Well, we don't know what we are going to encounter yet. Is it going to be very tedious? Is it going to be, we don't know unless we start working things out. But just make sure you don't give up, because it is something else. Yeah, I'm not discouraging you, but I'm just giving you a clue of what you are going to see. All right. Good. But it's very, very, very entertaining. Help you to at least feel good. Yeah, it's very, very, very entertaining, because the way the workings are is very fun. Okay, so let's move on to the Lambert W function approach. So using the Lambert W function approach, well, now let me write the question. 3 raised to the power x plus x is equal to 4. 3 raised to the power x plus x is equal to 4. Well, in our previous video, you remember we said that if you want to use the Lambert W function approach to solve a problem, make sure what you are solving, you get something like you should get something times e to the power of something. That is how the approach works. Something times e to the power of something. The something here can be anything else. It can be a number, it can be a letter, or maybe anything else. In mathematics, normally we look at numbers and then variables. Okay, so it's anything else in terms of numbers and then figures. So 3 raised to the power x plus x. How are we going to rewrite this to get something, to get it to look like something times e to the power of something? So in this case, our focus is always going to be x. We have this how many x here? We have 2x here. That is 1 and then 2. And this is another idea that's draw your attention of the approach that you should use. That is, anytime you see the variables to be, let's say, 2 in a particular equation, you can try applying the Lambert or W function. The motive is the Lambert W function just help you to eliminate one of the variables and then retain what? 1. In our previous video, we were able to eliminate one of the x and then retain 1, because at the end of the x and s, they are all the same. So we just get rid of 1 and then we maintain 1. So that is another idea of what using the there's another reason or purpose of what using the Lambert W function, just to eliminate one of the x and then maintain what? 1. Okay, good. So how are we going to rewrite it to look like something times e to the power something? How? Here we are having 3 raised to the power x plus x. How? So when we are writing it, will we use this one, or we will use this one, or both this and then this? Yeah, that is why Lucky wanted to find out, because the way if you are looking at it, here we are having what? Addition. But to use the approach, you should get what? Something times e. Here there is no e, but to use the approach what? Requested, or the approach what? Uses e. So you have to find a means of what? Getting the e. But here there is no way you are just going to get what? The e. Eh? So what are you going to do? Yes, what are you gonna do? Okay, all right, all right, all right. Okay, that's what we are going to do. The idea here is that because we want to use the Lambert W function, we are just going to reduce all of this. We're just going to reduce all of this by how? 3 raised to the power s. We're just going to divide all of this by how? 3 raised to the power what? X. The motive of doing that is because we want to get something times e to the power something. But here it is what? Plus. It is what? Plus. So the only way to get this one attached to this, or to get this one attached to this, is by what? Using division. Like if we divide it through, we will get this one attached to this one, and also attached to this one, and from there I think we'll be able to work it out using the approach. Because if you don't do it like that, it will be a little bit difficult to use the approach, because of how the approach works. All right, so we are going to divide both sides by 3 raised to the power x. Okay, then we divide this one by 3 raised to the power x, also divide this one by 3 raised to the power x, and also divide this one by 3 raised to the power x. Divide both sides by 3 raised to the power x. Now let's divide. Okay, here it will give us what? 1. And then here, now from the laws of indices, here we are having x over 3 raised to the power x. And from the laws of these indices, this one is the same thing as what? X times 3 raised to the power minus x. Alright? And then here too, we just write it as the same thing as what you are going to write for this one. Good. You see what I was telling you? You see what I was telling you? When we divide both sides by 3 raised to the power x, you see we've gotten this, and then this to be 1. And also we've gotten this, and then this to be 110. And you know, with the approach, something times e to the power something is what? 110. Just that we have something multiply and something being power, and then the approach will just take one of them out and then just give you 1. All right, good. So here we're just going to group like terms. So we will just send this one to this side, and then we will leave the one here. So it's just going to be either 1 is equal to 4 into bracket 3 raised to the power minus x minus this one, or 4 3 raised to the power minus 4 times 3 raised to the power minus x minus x into bracket 3 raised to the power minus x is equal to 1. Anyhow you do it, you're just going to get the same answer. Okay. All right, so what's next? What are we going to do? Well, Okay, good. Here, what we are going to do here is that I'm just going to bring out 3 raised to the power x from this and then this. You know, it is common on this side. It's common on this side. So we're just going to bring out 3 raised to the power whole minus x. And when we bring it out, we're just going to get 4 minus x multiplied by or times 3 raised to the power whole minus x. And that will be equal to 1. Okay. Okay, so here just going to rewrite it. Let's rewrite what is here. Okay, just going to rewrite it. We just rewrite it. 3 raised to the power x multiplied by 4 minus x is equal to 1. Now, 4 minus x is the same thing as what? Minus x plus 4. Minus x plus 4. Why are we doing it like this? Or why did we write it in this form rather than what? This is because of what you are going to see next. What you are going to see next. You know, the approach always, what is multiplying the e and what is powering this should be the same. So if we maintain it like this, it will never be the same unless we change it. So that is why I just change it from here, so that when you see the next approach, you really get the understanding. Okay, good. Okay, good. So what are you gonna do here? Still difficult to go by, though we've reduced it to something which is getting close to what we know, but still not easy. Well, what should we do? Okay, good. When we use the approach, when we rewrite this 3 here using natural log or using logarithm, you know, when you have any number and then you use logarithm to rewrite it with the motive of getting the same number back, the base of the log okay, so what I'm saying here is that if we are having something like let's say it is 3 raised to the power minus s, and then we want to rewrite it with the motive of getting this one back, we can use what? Logarithm or maybe natural log. When you use natural log to rewrite this one, you're just going to get e times what? E raised to the power natural log of what? 3 raised to the power what? Minus x. You know, the base of the natural log is what? E. And then we are having another e, which is what? The base. So it will just what? Cancel out. Okay, good. So when it cancel out, you're just going to get this one what? Back. So anytime you want to rewrite any number with the motive of getting the same number back, you can use the base of the log to raise itself to what? A log to the same base. What I mean by this is that if I want to get let's say 3, if I want to rewrite it with the motive of getting the 3 at the end of the day, I'm just going to write it using 3 raised to the power maybe log of, let's say we want 3 back, right? So log of, let's say 3 to the base of 3, and at the end of the day that 3 and then that base will just cancel out. Or if I want to, let's say, get 2 back, if I want to, let's say, get 2 back, I can use, let's say, c raised to the power log of 2 to the base of c. In that case, the c and the base of the log, which is the c, will cancel out and will just give me my 2 back. Okay, but here when we use what I just said, the Lambert W function will not be possible. Why? Because that one, it uses is what? E. So if I want to use logarithm in my next step, I have to use log, which require a base of what? E. So I have to use E to rewrite what? This one. If I use E to rewrite this one, I'm just going to get E raised to the power natural log of 3 raised to the power minus x. You know, the base of the natural log is E. And I don't know if I want to get this 3 back, it will just, that E of base of the natural log, which is E, will just cancel out with what? The base, which is what? E. And we'll just get what? 3 raised to the power minus x back. Okay, good. But so when we use natural log to rewrite this one, it will be this one times E raised to the power natural log of what? 3 raised to the power minus x. Though we've gotten the E, but what is on the other side, what is multiplying the E, is not the same thing as what is powering the E. In this case, what is multiplying the E is minus x plus 4, and then what is powering it is what? Natural log of 3 raised to the power minus x. You see, it's not the same. So to make what is multiplying the E and what is powering it to be the same, we are going to multiply this equation by 81. Why are we multiplying by 81? Is because of this expression here, that is minus x plus 4 or x plus 4. You know, when we use 81 can be written as 3 raised to the power 4. 3 raised to the power 4. And then when we multiply it by this one, also by this one, it will make this one, you know, the whole of this is one thing. So the whole of this multiplied by 3 raised to the power 4 or 81 will be, in terms of indices, to be 3 raised to the power minus x plus 4. So at the end of the day, what is powering this 3 here will be x plus 4, and then what is multiplying this 3 here will be what? X plus minus x plus 4, which is the same thing as what is here. So which means when we are rewrite this one using the approach, what is powering it and what is multiplying it will be all the same. Any question? If you don't get it, please kindly leave it in the comment section for me to help you out. Okay, good. So we are going to multiply through by 3 raised to the power 4 or 81. The value of 81 in terms of indices, or 3 raised to the power 4, the value of it is equal to 81, right? Good. So multiply through by 3 raised to the power 4 is the same thing as 81. You know, when we even write it as 81, at the end of the day, we have to, on this side, we have to change it to indices form, that is 3 raised to the power 4. So let's do it, multiply through using this one so that it will not confuse us when we are solving this part. Alright, I hope you understand what you are seeing. Minus x plus 4 times 3 raised to the power minus x dot. This dot here means it is multiplying. It's multiplying. So here it's not 1 point, it's 1 times 3 raised to the power 4. Okay, good. Alright, so as I was explaining, here the whole of this is one thing. Don't confuse yourself with this x plus 1, x plus 4 here. If you look at this x plus 4, you might think the law of indices will not work out here for you, which at the end of the day will make you confused. So just forget about what you are seeing here and take it as the whole of this one is what? One thing. If the whole of this one is what? One thing, then we only look at what? The base, which is what? The 3. And looking at this one, the base 2 is what? 3. And from the laws of indices, when the base are the same and it's multiplying, what do? We add the powers. So the power here is what? X, and then here 4. So it's going to be minus x plus 4. Alright, somebody may ask, what if this one here, 3 raised to the power 4, there was something attached to the 3 raised to the power 4, like let's say something like another maybe y, or maybe let's say maybe, or anything else is attached to this one, as this one looks like. What you just do is that if anything is attached to this 3 raised to the power 4 here, that thing will just multiply by this, and also you just add the powers as you are seeing, or as we are going to see in the next step. So if appears this side is, let's say, y 3 raised to the power 4, here this side will be y times this one times 3 raised to the power minus x plus 4. That's it. That's how you do it. So here is 1. So 1 times this one just give you the same thing as well. That. Okay. Now let's continue. So here, from the laws of indices, we will just add the powers. We just add this one and then this one, which is what? Minus x plus what? 4. And then here is what? 81. That is 1 times 3 raised to the power 4 will give us what? 81. The same thing as what? 1 times what? 81. Good. Now, you see what I told you earlier on. You know, what is here is the same thing as what is here, right? What is here is the same thing as what is here. So all we have to do is what? Get our E. Or, yeah. All we have to do is what? Get our E. Get our E. Good. So what we are going to do here is, we are just going to rewrite this one. We're just going to rewrite this one using what? Natural log. But before we use the natural log, because here there was no natural log, but we are just using it to help us solve our problem, we have to bring in what? E, so that the E will eliminate the natural log up from this one when we compute, and at the end of the day it will just give us the whole of this one or back. Are you okay? Sure. So we will rewrite the whole of this one using natural log, but before we use that, we have to raise it to we have to raise it to E. So we will just bring in E, and then we will write it as E raised to the power natural log of 3 raised to the power minus x plus 4. Minus x plus 4. Alright? Good. So minus x plus 4 times e raised to the power natural log minus x plus 4 is equal to 81. Is equal to 81. Now what is here is the same thing as what is here. Is that true? The answer is no. Why? Because here we are having natural log of 3 raised to the power minus x. Minus x plus 4. And here we are having minus x plus 4. So it means that, or we can say that if you compare what is here to this one, natural log is not attached to this one. So what we will do is that we just have to multiply through by natural log of what is here. Here is natural log of 3. When we bring this one to this side, it will be natural log of it will be minus x plus 4 times natural log of 3. But when you come here, it's minus x plus 4. So we have to multiply the equation through by natural log of 3, so that what is here will be the same thing as what is here. So multiply through by we multiply through by natural log of 3. Natural log of 3. Now let's multiply through by natural log of 3. Multiply through by natural log of 3. Good. Here we all know, so I'll not talk about it. Here we all know the most important thing is what? This one, not this one. That's why I didn't say anything about this. It's just what bringing the rewriting it using the law. So I'll not talk about it. So because it's an equation, whatever you do to the right hand side should be applied to the left hand side. So when we multiply this one, the whole of this equation by natural log of 3, this is what we are going to get. Now the motive is to just get what is here to be the same thing as what is here. That is why we are multiplying through by natural log of 3. Somebody may ask, how will I know that I have to multiply through by natural log of 3? Just make sure that the something powering the e should be the same thing as what the something multiplying the e. And when you look at it, we are having minus x plus 4 here. We're also having minus x plus 4 here. So it's only left with our natural log of 3. Natural log of 3. When you bring this one to this side, it's only left with natural log of 3. That is the reason why you multiply through by natural log of 3. Good. So here, as you can see, everything, something times e to the power something is just what? Working. Because here, what is here is the same thing as what is here. Just forget it, this one for the meantime. What is here is the same thing as what is here. Meaning we can apply the Lambert W function approach. I hope you are getting me, but I hope you are not getting confused because of the way the workings is going. Make sure you don't just get confused. It's something else. That is why I told you earlier on that it's a little bit something else. So don't just get confused. Or if you just get confused, whatever is confusing you, just comment it in the comment section and I'll sort you out. Okay, good. What are we gonna do? Well, you all know now that we have something times e to the power something. What is the next step? Take the Lambert W function of both sides. The moment you get other side of the equation to be something times e to the power something, most importantly, where we are having the variables or the letters, when you get that side to look like this one, or to get something like something times e to the power something, just go ahead and apply the approach. The other side, which is what we're having the values, most of the time when you apply the function on it, there is no way you are going to get something back, or there's no way you are just going to get the values to be in the same form as you are seeing here in order to get something back. So that one we just normally leave it as what it is. We normally leave it as what it is, and then we just focus on the variable side. And at the end of the day, whatever we will get for the variable will just be for the value of that variable, and we are good to go, whether the e is on it or not. Even if the e is on it, we just leave it as it, because there are devices that can compute it. If you have product law calculator, when you punch it on it will give you the real value of x. Okay, so let's take the Lambert W function of both sides. All right. Now, when you take w of this, what are you going to get? Remember, something times e to the power something. When you take into the when you apply the approach, you get what? Something back. So what is the something here? That is minus x plus 4 times natural log of 4, 3, or minus x plus 4 times natural log of 4, 3. All right. So you see what I said earlier on. When you apply the function, it will just take one of the variables away and it will just maintain 1, and that is what you are seeing here. We are having something to the times e to the power something, and then at the end of the e and one of the something is gone, and it has just given us one of the something, which is x minus x plus 4 times natural log of 4, 3. Good. Now, how are we going to find the value of x? The question is, can we also rewrite this one to look like something times e to the power something so that we will get our something back? Just look at this one. In this video, and then with regards to this question, the answer is yes. Yes. I said in this video, and in regards to this question, the answer is yes. But it might be that in your problem that you are solving, the answer will be no, because that's why I said that it is not always possible that you can, the value side, you can rewrite it to get the value of to get something back. So if it appears that it is not possible, you just leave it as it is. So here, if it appears that it is not possible to rewrite this one to get something back from this, we'll just leave it as it is, and then we'll just concentrate on this one and look at how we can find the value of x, and then we are done. And whatever we will get will be for the value of x, no matter the letters and the variables, no matter the no matter what let me say, no matter the letters and the variables will involve on the other side. Well, here is a variable that is w. This one represents the value of any integer at all. That's how the Lambert W function works. This w here represents any integer at all. So when if it appears it's not possible, and then you get the value of x, like x is equal to this, w of this over this, blah 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 blah. That is why we use the product law calculator. If you point it on the product law calculator, the product law calculator will be able to know the exact integer that's supposed to be here. We cannot tell the exact value of w here, so we have to leave it as it is, so that when we point it on the product law calculator, it will just determine it. That will determine the actual value that's supposed to be here, and it will use it to simplify it and give you the value for x. So we will just leave it as it is, if it appears that we can always write this one to get something from it. But in this video, it is possible. So let's look at how we are going to rewrite this one to get something from this. Well, this one is natural log of 3. 3 raised to the power 4 is the same thing as 81. But here you have to think. Here it just you have to think critically before you can get it. It's something else. That is why I'm saying don't just get confused, because it's it's very fun. It's very fun. It forces you to think. It forces you to think. This question is something. If you want to use the Lambert W approach, something else. But I don't think it also help you be fond of thinking in advance. This one, if it is an exam to me, I'll just say it's not possible, and leave it and go. No matter what, the lecturer will just give you your marks, and then you are good to go, because it's not how will I know that have to write this one this way to just something like that, something like that. But well, in this video we are just going to find out. Don't worry, we're just going to find out. So how are we going to do it? Well, what we are going to do here is that remember 3 raised to the power 3 is what? 27, right? Good. And 27, if I want to get only 3 from it, what should I do? We divide it by 9. If you divide it by 9, yeah, you get 3. But what if I don't want division? Because if I divide this one by 9, it also affect this one. So I don't know if they're just going to be you see, when you divide it by 9, it will be something else, but still might work out. Yeah. Alright, so okay, we will not divide this one by 9. We will not divide it by 9, but yours you can try dividing it by 9. I think it will just maybe work out for you. Yeah. So what we are going to do here is 3 is the same thing as what? Cube root of 27. 3 raised to the power 3 times 3 raised to the power 3 times 1 over 3. It will just give you that is what the cube root of what? 27 is what? 3. So we will just write this 3 as cube root of what? 27. Why? Because we want to get something from it. And by writing this one as cube root of 27, we will write the 27 as 27 raised to the power 1 over 3. And that 1 over 3, 81 multiplied by, or 81 divided by 3 will give us what? 27. So at the end of the day, we will get what to be here and what to be here to be the same. So the moment you get what to be here, what is here, and what is here to be the same, we can use the E to rewrite one of them and apply the approach. So that is the reason of trying to rewrite this one, just to get what is here and then what's here to be the same. Okay, so we will write this one as cube root of 27. Cube root of what? 27. And then we will multiply, apply the law of indices. That is the quotient law of what? Indices. And then we will multiply this one by that 1 out of 3. And that will give us what? 27. And when we get it like that, we can apply the, we will be able to rewrite it to get something times e to the power something and get something from it. Okay. Good. So we will write this one as well. 27 raised to the power 1 over 3. 1 over 3. And that 1 over 3 will come and multiply this one. And that 81 multiplied by 1 over 3 will give us what? 27. Or? Yeah. Good. So here it's just coming to multiply this one. So when you multiply this by this, it will give us what? 27. Alright. Now here is 27 and here is what? 27. Meaning we can apply the like what we did to the other side. That is we can rewrite this one using what? E and the natural log. So it's just going to be natural log of 27 multiplied by e to the power natural log of 27. You see, very simple, but it's not that simple because it's not easy to get to know that this one, this 3 here is same thing as this one, and then this one is same thing as this, and then it's something else. If it is not possible for you, just leave it as it is. But just that in this video, I'm just showing you that sometimes it is possible when you try other means of rewriting, applying other different areas, something like that. When you do that, it sometimes helps. Okay, So here I'm just going to rewrite this one using what e and then natural log. Alright, here, is it the same thing as something times e to the power something? The answer is yes. The answer is yes. Although we have already taken the w of this. Alright, so now since it is something times e to the power something, this w just going to go off with one of the w, one of the natural log of 27 and then the whole e, and to just give us a natural log of 27 back, to just give us one of either this or this word back. All right, so guys, you see what we have gotten so far. Yeah, that's what I was telling you, that this one is something else. But if you try and then get to do everything, you see that it's really cool. It's really cool. So this is where we have reached so far. That is x plus minus x plus 4 times natural log of 3 is equal to natural log of 27. So how are you going to find the value of x? Here we are having natural log of 3. We are having x plus minus x plus 4 here, but with this side we are having only natural log of 27. We can't do comparison. So what are you going to do? Okay, can we divide both sides by natural log of 3? We will divide this one by natural log of 3 and also divide this one by natural log of 3. Alright? Yes, maybe it is possible, but here I'm not going to do that. Yes, you can try that one when you are working yours out. Yeah, maybe try dividing this one by natural log of 3, so this one by natural log of 3 to get the value of x. Try doing that by here. I'm not going to do that. So what I'm going to do here is that this 27 here is the same thing as 3 raised to the power 3. Here we're having natural log of 3. So when we get this one to be natural log of 3, we can do comparison and then we equate the other figures that we are going to get. What I mean is, when we get this side to be natural log of 3, whatever that will be here will be equated to this one, because this one is the same thing as what is here. Alright, so we will write this one as natural log 3 raised to the power 3. If you write it as 3 raised to the power 3, if you apply the quotient law, it will be like this. This one is the same thing as this. So 3 times natural log of 3 is the same thing as natural log of 27. Now, as I was saying, by comparison, what is here is the same thing as what is here. Therefore, what is here should be the same thing as what is here. As you can see, this one is equal to this. So you will just equate this one to this one to get the value of x. So by comparison, minus x plus 4 is equal to 3. Minus x plus 4 is equal to 3. Alright, so let's find the value of x. We'll just bring this one to this side and then we are good to go. Alright. So just bring 4 to this side and to be minus x equal to 3 minus 4. So minus x is equal to minus 1. Minus x equal to minus 1. So we divide both sides by minus 1 and that is going to give us x is equal to 1. X is equal to 1. So you see, both approach has given us what? The same value of what? X. The same value of what? X. It's very, it is, the indices approach is quite simple, but not that simple, because the question is to know that I have to rewrite this one in this form to show this is the problem. That is why I show you both. But is I will not say because I've been able to solve it. I will say it is easy. I will not say it's easy. It's not all that easy. Yeah, to be fair, yeah, it's not all that easy. It can take you maybe a lot of time to just to find out this one when rewritten in this, or this one when we write this way, it will help you solve your problem. It's not that easy. Sometimes you just have to be trying to just to find out which one will just make the equation solvable. But it's fun, it will help you, think in advance, or maybe develop the habit of thinking more. Yeah, let me say it, thinking more, because if you don't think in advance, or if you don't think very well, it won't be all that easy for you to know that this one is the same thing as this, so have to do it this way to get this way. There's something like that. Yeah, you see, by doing all those things, we had s to be all 1. Yeah, it's cool, right? Yeah, sure, it's cool. So guys, anytime you have question of that nature and you want to use the Lambert W function to solve it, I think what you just seen is how you should go by. But please note, the other side, the value side, is not always possible. If it appears to be not possible, you just leave it like that, and then just work out the value of what? X, and then you are just good to go. If you don't get any numerical value, just forget it and then write whatever you had for S as what? The answer to it, and then you're just good to go. Everybody knows that sometimes it's not easy to get something back when in terms of what the numerical side. But if it is possible, and then you just do it and just get something from it. But if not, you just forget it. All right? Oh, that's good, right? Sure, that's good. All right, so Lucky, your question has been answered, and if you find it difficult getting understanding from any of the steps, you just let me know in the comment section, or you just let me know. And also, just if everything appears to be very understandable for you, just make sure you share it with your friends, and then make sure you just subscribe. Yeah, you share it with your friends, invite them also to come and then benefit. Okay, that's good. If you have any question, please just reach out, and then I'll just sort you out. Okay, that's nice. So guys, that's it for you. X is equal to 1, and then you can do the proof aspect yourself. You can put in the 1 into the equation to find out if you just get it to be equal to 1. But for that one, I'm not going to do it here for you. Okay, all right. Therefore, X is equal to 1. All right, that's it, guys. Please, if you like this video, kindly give it a thumbs up, subscribe, and comment. Thanks for watching, and I'll see you in another video. Bye.